All right, so the algebraic expression, the actual definition is when variables stand for numbers and when variables and numbers are combined using the operations of arithmetic. Okay, I ran out of space. I'm supposing that some of you guys did too. It's okay, we'll make more room. So that is an algebraic expression. Okay? An algebraic sentence is an expression related with a verb in symbolic form. So, an algebraic sentence, this would be an algebraic sentence. Correct? Okay? So A is equal to S squared times the square root of 3 divided by 4. There are verbs happening to those variables and numbers. Squaring a number, taking the square root of a number, that's a verb in math language. Okay? So some various things that you need to know or remember, some different symbols. And hopefully all of these you remember. I know that some people forget which way the arrow points when you're saying is less than, is greater than. Okay? So just go through and make sure you understand those numbers. Whenever you see a line through something, that means not that. So let's look at the first expression. Example 1. Joseph has a collection of 1,380 comic books and buys 17 new titles every month. If Joseph continues collecting comic books in this way, how many comic books will he have after m months? How would you write that in an algebraic expression? Yes?
1,380 books plus 17.
Yep, 1,380 books plus 17m. Okay, so one of the little giveaways that you have when you're writing expressions, if it says every something, you know that's probably being multiplied. Okay, if you also see the word per, something per something, that would also tell you that's probably being multiplied. All right? So look at part number 1b. I'm going to give you a second. I want you to try to figure this one out on your own, and then we'll put the answer on the board, okay? So try to do this on your own. No, that's not what I wanted. Okay, so Maria collects 17 stamps. And she already has 860 stamps in her collection. She plans to buy 20 stamps each month. I hope that you guys got 860 equals 20, 860 plus 20m. Yeah? Okay. All right. Moving on. Evaluating expressions and formulas. Okay, so evaluating expression. When they ask you to evaluate an expression, it really means replacing the variables with some numbers. Okay? So you can write this in this box, substituting numbers. For variables in an expression. Okay? So if you're going to be substituting numbers for variables, most likely you're going to have to do something called order of operations. How many of you guys remember the word Pemdas? Good. Yep. Okay, so we need to review that real quick because that's an important part of this section. If you need more than what I'm talking about today in class, you can look at the video that's on the Moodle. It's just a whole video on Pemdas, okay? But we're going to review it. Pemdas can really be expressed as GEMDAS, okay? I like that one better. What does G stand for? What did P stand for? Parentheses. So in GEMDAS, this stands for grouping because you use different types of parentheses, right? So this will be grouping. Okay. What does E stand for? Exponent. Good. M, multiplication. How about D? Division. How about A? Addition. And then finally, subtraction. All right? So when you have any of these things in your sentence that you're trying to solve, your expression, you need to do first the grouping. Then you would look at exponents and so on. All right. So let's look at the next problem. Do you guys remember what formula this is? Quadratic formula. You might want to just write that somewhere on your page because this is important. You'll be really digging into this more this year and also in FST later. All right. All right, so negative b minus the square root of b squared minus 4ac over 2a. We are supposed to evaluate this. I have these things right here. What do I do with those? Plug them in. So I'm going to recommend when you plug these in, because sometimes you might have a negative, like b is negative and c is negative, use parentheses. So negative parenthesis, I'm going to put in negative 1 minus the square root of negative 1, notice I'm still using parentheses, squared, minus 4 times a, which is 3, c is negative 4, and that is all going to be over 2 times 3. The reason I'm telling you to use parentheses is it helps to prevent you guys from dropping negatives. If you use your scientific calculator or your graphing calculator, you can include those parentheses and then you'll know you'll get the right answer. Okay? If you happen to drop that negative, it'll make a whole different problem for you altogether. Alright? So, let's do PEMDAS here. Do we have any grouping going on? It's not obvious. What would be the grouping symbol in this case? The square root, right. This is like having a grouping. So we're going to look at inside the square root first. Okay, so inside the square root, I can see that there is an exponent, so I'm going to do that one first. What's negative 1 squared? 1, okay. Minus 4 times 3 times negative 4. So that would be, what is that? $48? Yep. And it's a negative 48. All right. And then on the bottom we have 2 times 6, which is 6. We still got to solve the inside of this yet. Yes, it's going to be 49, so it'll be the square root of 49. What is negative 1 times 1? Yeah, so it'll be a 1 plus that over, actually this should be a minus here, right? Because it was minus before, sorry. 6. What's the square root of 49? 7. So we got 1 minus 7 over 6. What would be my next step? Subtract it, yep. So in a sense, this is grouped on the top, right? That 1 minus 7. So we need to do the grouping first. So it'll be negative 6 over 6 or negative 1. Any questions on that? All right. Did you guys get the same thing I did on that last one?
I got
15.8. Okay, so as we see, here's the mistake. 36 minus 25 is not 9. So it's really 11 plus 16, which is square root of 27. So what did you guys get after you have 6 plus 4 plus the square root of 27? What'd you get? What was it? I don't have it in my head, honestly. 10 plus, what's the square root of 27? Come on, guys, you can jump in. 5.2. So it should be 15.2, right? Okay. All right. Good paying attention and staying on top of things. All right, so let's keep going. A sentence stating 2 expressions are equal. That's what an equation is. And my spelling is not good either, so if I misspell something, you can tell me. Sentence stating 2 expressions are equal. Okay? A formula is an equation stating that a single variable is equal to an expression with one or more variables. So these are some examples of some formulas. There's billions more out there. Let's look at example 3A. A kilowatt hour is 1 kilowatt of power used for 1 hour. Right? What does it cost to have a 60-watt light bulb turned on for 33 hours at a cost of 9.53 per kilowatt hour? How would I write the expression for that? Well, first of all, we know we have a 60 kilowatt bulb. So we're going to do something with a 60 watt bulb. Okay? And we know that it's on for 33 hours. At a cost of 9.53 cents. You see that word per, so we're going to have hour on the bottom, but it's a kilowatt hour. There is one problem with this. I can't multiply this all out. Why? What's What's wrong with my expression right now?
Because the endings are the same. It's
Right.
like hours and kilowatts.
Yeah. So we have here, we have kilowatts and we have watts. How do I convert that watt into a kilowatt? How many watts are in a kilowatt? What do you think? Just make a guess. 100 is a good guess? 1,000, yep. So let's change that. Let's do this. Let's do 60 watts times 1, we'll say kilowatt, over 1,000 watts. Okay? Times 33 hours times 9.53 cents per kilowatt hour. Right? So if I multiply all that out, you should get 18.87 cents per kilowatt hour. Or cents, totally. Just cents. All right? The watts cancel, kilowatts cancel, the hours cancel. So you're left with just cents. All right. So it cost 18.87 cents for that 33 hours. It's not very much, right? Let's look at this. It says, give a formula for the cost in terms of the three numbers in the problem. Well, let's give P the number of watts. Let's just call it that for power, right? T, number of hours. And U for the unit cost. So how would I express the total cost then using these variables based on what we did up here? So what did we do? What operation did we do all the way across? Multiply. So you know I'm going to multiply those three, right? P times T times U. What did I have to divide by? Yeah, 1,000. 1,000 watts for a kilowatt. So that is what it is in terms of variables. Now I'm going to pause here the video because I want you guys to try to do number 3B by yourself. It's the same kind of problem. Okay? Go for it. At 4.72 cents. Okay? So, having a spiral bulb can reduce costs quite a bit. Alright? So, today, your assignment is listed on the Moodle page and your classroom web on the Google Classroom.